It is a pleasure to welcome you to the pitch sharing session of the third edition of the lecture series on advancements in geotechnical engineering, from research to practice. At the pitch sharing session we asked the participants to explain their research with 3 slides and within 5 minutes. They were judged by a 4-member judging panel and the audience members. The pitches that were adjudged as top 3 by the judges and audience members are being shared. The following presentation was ranked 1 by the audience members.
So good morning, everyone, and thank you so much for your introduction. So it's my honor to be here. And the important point is we can produce the biocement through several mechanisms. But in this study, we are mainly focusing on microbial-induced calcium carbonate precipitation mechanism. We can call it as MICP. In our case, the biocement is calcium carbonate, and we know there are a number of bacteria inhabiting around us. But the ureolytic bacteria, which means it's a kind of bacteria, they also produce enzyme that has the capability to precipitate the calcium carbonate from a particular chemical solution. So we can call that chemical solution as cementation solution. So in this study, we are using Sporosarsina pasteurii. It's a well-known ureolytic bacteria that is widely used to produce the biocement through MICP. So for the further understanding, we shared biochemical reactions here, and the urea and calcium chloride are the key ingredients of the cementation solution. And we are using 1 mole per each for our cementation solution, and the treatment will be continued for certain days. The next important point in our study is the demolition waste. Generally, it contains the mixture of different materials, but we are focusing on concrete aggregates because according to the previous studies, they confirm it has the capable to replace the natural aggregates. Due to that, we collected the concrete demolition waste from our environment and we recovered into different size of particles. Then we prepared a mix design for concrete aggregates. Then we packed those samples in different cubic molds with different mix designs. We are following the saturated treatment condition, and we injected the bacteria solution from the top of the sample mold, and we left the solution for 2 hours. And we drained the bacteria solution from the mold. Then we injected the cementation solution, and we kept it for 24 hours. And we are replacing the fresh cementation solution day by day. Likewise, we are continuing the treatment method in similar manner. I want to mention here, we are also providing the nutrient growth with cementation solution for the efficient bacterial activity. I would like to mention here, we are still in progress of initial laboratory scale test, and by the end of this study, I hope this is to be promoted to the real field. And if we come to the significance, we know conventional cement production is increasing with population growth and demand. Due to the conventional cement production, the CO2 gas will be emitted to the environment and it will cause several environmental problems. Likewise, if we take a municipal council, definitely there will be huge amount of demolition waste, and it will take many problems while managing those solid waste, as well as it needs huge space in landfills also. So importantly, the natural resources are already exploited, and definitely we have to find alternatives for those problems. And so if we implement the biocement in the geotechnical or construction industry, at least we can reduce considerable percentage of ordinary Portland cement production, and it will help to minimize the CO2 emission, as well as due to the recycling process of demolition waste, especially concrete aggregates, we can practice the sustainability, and it will help to protect the natural resources instantly. So we have to practice the sustainability, and we have the responsibility to serve our environment. And thank you so much for giving this opportunity. Thank you.